Now we're going to apply the concept of resistors connected in parallel. So resistors connected in parallel are called current dividers. Why are they called current dividers? Because if you connect them in a circuit and the total current is flowing from the power source, from the negative terminal, this is the total current, we can call it IT. When it gets to this branch, it splits. So you get I1. So you get I1 going into resistor 1, and then I2 flowing downwards. When it gets to this branch, it splits again. So you're going to get I3, and you're going to get R4. Because of how the circuit is connected, or how the wires are connected in the circuit, each and every time a current passes a branch, it splits. But one thing to note is that once all the current has flown through the circuit and it's coming back to the positive terminal, all of it joins again in this terminal and it becomes I total. So the total current that flows into each of these branches is equal to the total current that flows back into the battery, or the cell, or the power source. So now, in order for us to calculate the current throughout the whole circuit, the only thing we're giving in the data is V total, which is the voltage from the power source, of which is 20 volts. And we're given 3 resistors. One is rated 5 ohms, 10 ohms, and 15 ohms. In order for us to calculate the equivalent resistance, we say 1 over R EQ. EQ stands for equivalent, is equal to 1 over R1 plus 1 over R2 plus 1 over R3. It's pretty easy to calculate this because you say 1 over REQ is equal to the first resistor is 5 ohms, the second resistor is 10 ohms, and then the third resistor is 15 ohms. Because I don't have a calculator with me, I'm going to use math. So the lowest common denominator is 15. 5 into 15 is 3. 3 times 1 is 3. 10 doesn't go into 15, so this is the problem. Okay. So all you can do is that you can put this thing in your calculator and say REQ is equal to 1 over 5 plus 1 over 10 plus 1 over 15 to the power of negative 1. And whatever answer you get from there will be your equivalent resistance. If I put this in my calculator, trying to put this in a calculator, you get 2.72 ohms as your equivalent resistance. So equivalent resistance is 2.72 ohms. Ohms, which is the measurement unit for resistance. What we want to find is the total current. So we go back to Ohm's law, which is IT is equal to V total over R total. We know that VT is 20 divided by 2.72, which is going to give us it gives us 7.35 amps. And that's how you find the current in a circuit that is connected in parallel. So what I've taught you now is how to calculate the equivalent resistance for resistors connected in parallel, how to calculate the total resistance for the resistors connected in series. Then you'll need those two concepts because in an exam or test situation, they don't usually put something as simple as this circuit, they'd probably combine both of the circuits, the series and the parallel circuit, and you have to use the rules that I've taught you right now in order for you to calculate the two. So what we're going to do now is do an exam type question or a test type question where we combine the series and the parallel connections in one circuit and then calculate maybe the voltage across one resistor and the current through a resistor that is not directly next to the power source. So that means you have to apply concept like current division and voltage division in order for you to understand. And I know that I may be speaking fast, that's because of we're trying to make the video as short as possible so that it can be distributed on WhatsApp. So if you don't hear what I'm saying, you can always rewind or press back or pause it in order to see what I'm writing on the board and then write it down for yourself.